think we might as well make a start. We've got 21 of you here at the moment. So, morning everybody. Today's topic is recirculating filters, and we of course have Mark Armstrong to thank for that. He suggested that at the last meeting. And as we all know, recirculating filters are growing more and more common, particularly so in new builds, where efficiency and retaining heat is really, I suppose, the main design priority. But the problem with recirculating filters is that they require heavy management to ensure that they don't pose a risk to respiratory health, in poor design and in maintenance. So I just wanted to kick off the conversation first by asking you, how often are you finding recirculating filtration systems that have failed?
Hi, Louise. I don't know if it's just me, but you're breaking up a lot.
Or am I?
When you're coming through.
Let's try a new device. I'll try a laptop. I'll be back in a minute.
Shall I jump in while we're waiting for Louise? One of the issues I've got at the moment with the HSE approach is that we should be taking readings at recirculating filters, but I can't get clarification on how, why, when we do this. So part of the question I had for this was, what are we doing? Why are we doing it? What's people's views on this? For the various different types of systems we've got, be it for solvents, for wood dust, flour dust, whatever it is that's recirculating, what approach are others taking? I don't think a very quick, simple reading taken once at a recirculating filter tells you very much at all. I'm not sure why you would take that necessarily, unless you could relate it to operator exposure. Not telling you a great deal. But we're seeing it more and more on reports. System failed, hasn't got any recirculating filter, air assessment data, or anything like that. So yeah, just putting that out there in terms of what others think of that, what others' views are.
Hi Mark, it's Kathryn. Can you hear me okay?
Yes, I can, Kathryn.
Okay, so I haven't really thought this through, but just initial reactions are that as good LEV testers, I think we try to take on quite a lot of the issues without a lot of support sometimes from the regulators. We do see recirculating filters that fail when we go and do a test, but I think your point is that we go once a year, and the responsibility really lies on the client to make sure that those recirculating filters are working okay for the whole year. So my opinion is that rather than actually doing a test once a year, that it would be better if we were to do anything, and the regulations would be better placed to make sure that the clients have got the right processes and procedures in place for managing it themselves in-house. So that's just, I suppose, my initial thoughts.
I agree, and I think part of the majority of the systems that we're looking at in this situation, I think, are predominantly wood shops, where you've got things like the cloth filters recirculating back into the atmosphere. Correct me if I'm wrong, but I think that's what we're talking about in the majority of cases. Or welding fume as well. That's another one. That's a whole other can of worms, with gases and things being recirculated back into the atmosphere. But the guidance really isn't clear. It just says undertake air sampling. But my view is, unless you're doing operator exposure assessment so you can relate it to the actual workplace exposure limits, then why do it? You know, it's indicative at best, but that's all you're getting, an indicative reading. I don't think it's enough to fail an LEV system if you haven't got that data, just for the recirculating filter, if you have operator exposure assessment data, for example. And this comes back to something we talked about at the conference. Should you have operator exposure assessment to go hand in hand with the LEV report? I think for the majority of cases, the answer is yes for us.
I think it all adds up to the bigger picture, doesn't it? You know, the handheld equipment, it's not perfect. It's not, you know, it's not an exact science. It depends where you hold it, and it depends how you're doing the reading. But together with your visual assessments and what you see happening in the space, what you see, the condition of the filter, and whether you can see dust coming through or telltale signs, then that just adds another element of evidence to your case. But I do think that you do need air monitoring, proper air monitoring, to prove control effectiveness. And I think, you know, as a test, someone who tests systems, you're going to be putting that in your report almost every single time. Again, you're only testing on that day. I see far too many recirculating filter units without the alarms, without the warning devices that are needed to tell the operator if that filter is passing dust or fumes. I also think there's a number of suppliers on the market who just don't understand what their recirculating filters are actually recirculating. Mobile weld fume units, yeah, they take out the particulate, but they don't take out the gases, not that I've seen. And yet they're sold and used for, you know, long periods of time in quite small spaces. They should come with a health warning, in my opinion. Jane?
Yes.
I think you just need to speak.
Oh, right, okay, I'll put my hand down.
Yeah.
Wasn't sure what the protocol was. I think recirculating filters have a place. We haven't differentiated between recirculating filters within a workplace and recirculating filters situated outside, because the two exist alongside each other. And the problems of the filtration being ineffective apply equally to both. But in one instance, there is exposure to workers in the vicinity, and in the other instance, there isn't initially a problem with exposure to workers in the vicinity, because what happens is, after a period of time, there's deterioration in the flow rates because of the filter issues, and that affects the effectiveness of the extraction generally. So that will then affect the workers in the workplace. So there is a slight difference between the two in terms of how quickly people working in the workplace are going to be affected by that deterioration of the filter. There are plenty of methods of putting alarms and controls in place to identify when there is a problem with the LEV, and we all know that that's highly recommended. It's not given as essential. The HSE use those weasel words that, you know, well, if you don't have some form of airflow indicator and pressure gauge, how else will you always know that the LEV is effective? I wish they'd just, you know, jump off the fence and say what you need is effective gauges. Because with those in place, provided, and this is a big proviso, provided the employees understand what those gauges mean and understand what they need to do and act upon it, then there's no specific issue. The issue is when they're allowed to deteriorate. And I'm very much in favour of using direct reading instruments to supplement all of the other information that you've recorded during your LEV assessment to see whether or not there is potentially an issue. It gives another layer of data. If you can identify that particulate is passing through the filter, or you can use one of the other monitors that are readily available. There's all sorts of VOC monitors and monitors for gases and mists that will identify whether or not the substance that you're dealing with, or an appropriate tracer substance, is being leaked back through the filter. And I have said for many years, and I still say, I fail to understand how anyone can carry out routine LEV testing without additionally doing some form of sampling in the return air of the filter, whatever the substance.
In that instance, Jane, you know, if you get a result, what are you comparing it to? If you're not comparing it with workplace exposure, it's indicative, and I'm not disagreeing with you from that point, that it's indicative that there is dust coming through the filter, and it's maybe pointing you down the direction of you need to then do some air sampling. But you can probably tell that by looking around the filter anyway in some instances. I'm not saying we do or don't in every situation, but I think if you look around the filter unit, if there's dust on the floor, it's clear it's coming through, or the management of it isn't right. But it all...
There isn't always dust coming, you know...
Yeah, it's still... Sorry,
Mark,
Jen,
yes, in extreme circumstances...
Just let me finish.
Yeah.
Sorry, Jen, just let me finish. I'm just going to say, if you've got some results that are indicative, it's still saying, you know, that if you can't relate it to workplace exposure limits, it's it's not telling you an awful lot.
Well, with respect, it is telling you something. You don't always have dust and deposits around to tell you that the filter's not working effectively. What it does tell you is that the filtration is not effective and that the filters need to be replaced. And it will often tell you that before there are other levels of indication. And what you do at that time is you recommend replacement of the filtration if you feel it's going to be up to the job when it's been replaced. If not, you're recommending something else. And you would also, in most circumstances, recommend some personal sampling to be carried out, because what you've done is just an indicative reading. And particularly in circumstances when you can't actually see deposits around, it can be very useful to say to the operator, to the owner, to whoever you're liaising with, come and take a look at this, and show them what the readings are coming through the filters. And that, you know, you can put 1,000 words in a report, which people will ignore. You start having photographs, you start having a graph that you can show them, you start having a direct reading instrument when you can say, have you got a minute, can you just come and look at this? It really emphasises to the people on the ground that there is a problem and they need to do something about it. And workplace exposure limits are not the only standards that we're working to. Obviously, a lot of things need to be, as far as reasonably practicable, below the workplace exposure limit, but there are also standards for various types of extraction which actually specify what the amount of returned air should be in the cleaned filtered air in the workshop. So the standards for chip and dust extraction systems, for example, require that alarms should be going off at something, I think it's 0.3 milligrams, and that the system should automatically shut down at 0.2, or maybe it's 0.1 milligrams. I'd have to go and check the standard to be sure. But there are very low levels of dust being returned through the filtered air, which should trigger an alarm. Frequently that alarm isn't there. And these standards are applicable to larger wood waste extraction systems, but some of them also apply to the smaller systems. And there's no reason why, if you're working with a large extraction system, there is an unacceptable, very low level of returned particulate. Why wouldn't you also apply that to a smaller system? The lungs of the workers in that smaller workshop are no less sensitive to disease and deterioration and harm than the lungs of the workers in the larger workshop. And just because that employer chose to install several smaller units rather than one big unit doesn't mean to say they should be allowed to pollute the lungs of their workers. I really don't understand the reluctance to use what is not a particularly expensive tool to add to the information, and very importantly, add to the illustration that you can present to the users. Because what all of us want is for the people using the equipment to be using it and maintaining it properly. And anything we can do to demonstrate to them that the fact it appears to be sucking is not the be all and end all. There's a lot more to it. It's got to be in everybody's interest. We're all working towards that goal, aren't we, Mark?
I wouldn't disagree with that at all, Jane. What I'm saying is, and I think you're right, it's the defining the limits so that we're all working to the same standard. So, I'll pick Adrian as an example. He might say, right, we pick, if there's anything coming through the filter, we fail it. You might be saying 0.3. We might be saying 0.5. It's having a uniform standard across the industry that we're all working to. That's the difference, where at the moment we haven't got that. Some people are saying we're not using that figure. Some are picking figures like you say. And I think that's the key. It's trying to define what we say is okay.
What I think is reasonable is to say that the maximum would be 10% of the workplace exposure limit if it was something that doesn't have to be as low as reasonably practicable. And that would be what we would work to, and we would alert the client to the fact that there is concern if we were anywhere between 1/3 and 1/2 of 10% of the workplace exposure limit for the substance that we're using, unless it's something as low as reasonably practicable. And then you need to be looking at the other data and advising accordingly. And I think that's quite reasonable. So with wood waste at the moment, I would ignore the fact that it's sort of 3 milligrams and going to 2 milligrams, and I'd work to the 2, because nobody's going to go suddenly leap up and down. Is it next January or the January after when it changes and suddenly start doing something different? So we should all really be working to as far below the 2 milligrams. So 10% of that is 0.2, and we would be raising an alarm if it was anywhere, up to 0.1. We'd be looking for it to be significantly below that. My experience talking of woodworking systems is that it is perfectly possible for a properly designed, well-maintained woodworking system with recirculatory filters inside the building to be significantly below 0.1 milligrams of particulate per cubic metre in the returned air. And if it was anywhere near that figure or above it, alarm bells would start ringing.
I think the other issue we've got is that's fine, but it's then relating it to potential exposure. So if you've got a woodworking system that's putting out 0.3, but it's only used for half an hour a day, and the workplace exposure, actual exposure for the operator is negligible to zero, then is that okay? So, and this is what I'm trying to do, is trying to relate this, what you're getting at the filter, to actual exposures. So you're building in the whole, how often is the system used? How heavy is the usage on that system? We've got to account for all of that. We can't just say, oh, it's 0.3, or it's above, that's a fail. Because actually, if it's only used for 10 minutes once a week, that might be okay.
Sorry to jump in.
No, I don't think that is okay. Because
I'm not saying it is. I'm just saying that as an example, that you've got to relate it to the usage and the time it's used.
This
you
goes
only
back
need
to
to do
comparing
that
it
if you're
with
trying to relate it to a personal exposure, which we're not trying to do. We're not specifically relating it to a personal exposure. We're relating it to the statutory obligation to maintain that LEV in good, clean, effective condition at all times. It's then up to the client to decide, well, we only use it for half an hour a week, so we don't think the HSE will come and kick us, so we're not going to do anything about it. But we need to tell them whether it's effective. And if they're only using it half an hour a week this week, who knows what's going to happen next week or the week after, when they get a big order in or when circumstances change.
You have to relate it to operator exposure, and that's the whole purpose of that system, is to control the operator's exposure. So, you know, it's all directly relatable to the exposure for me, and you have to account for what they're doing. And if it's defined in the report that we say we tested this under this circumstance based on this situation, and in this situation it's okay, you know, I think you have to look at that. I think you can't discount what they're actually doing and the potential exposure of the operators.
Guys, if I can interject with, we don't want to have it just as a bipartisan discussion. Both Melvyn and Craig have both got their hands up. Could we allow them to say something, please? And just to update you, I've had a message, you probably all had it from Louise. Apparently her microphone is broken and she's trying to set it up on her computer. So that's the reason we're not hearing from Louise. So I've jumped in. Melvyn, Craig, tell us what you'd like to say.
I'm happy for Craig to go before me.
Thanks, a very quick one. So HSE say for recirculating systems, they should be installed with a high efficiency. The SOC filters are by no means high efficiency. So how on earth can we use these systems? Certainly in woodwork systems, because that's when you see the SOC filters, but even the little portable weld systems, they don't have a high efficiency filter on nine times out of 10. How do we think the suppliers are able to put this into market as testers, commission engineers, service engineers? How do we go about this, do you think?
For me, there's some really good points that Mark's made. How do you make the assessment? There are procedures for undertaking tests, but they all have limitations. For instance, if you look at our current BS standard for recirculation fume cupboards, they tell you that you can release 800 parts per million of IPA inside the cabinet, and provided you're not measuring more than 40 parts per million at the end of the filter, that's okay. That filter has passed the test. That's not to say that 40 ppm is acceptable to the end user. Now, they're currently looking at recirculation filtration fume cupboards in Europe, and what they're suggesting is you only release 200 parts per million, and you shouldn't be measuring more than 1% of the OEL at the end of the filter. So it's not just necessarily whether you wish to undertake a test, it's what type of test are you going to undertake. Also, we have to consider some of the limitations that the test procedures also present. If we're doing tests inside an intrinsic type test room, we can set the conditions to be exactly what we require them to be. But when you're performing tests out in the field, there are other influences that are in that area. So, for instance, if you're taking this instance, IPA, and you're using a PID to do your detection, you could be picking up background levels of coffee, eau de cologne, air freshener. So your background levels could be higher than the actual value that you've decided is your benchmark. So Mark has got a really good point. Where do you start with it? How do you reassure the end user that you're actually evaluating what they need to know? Sometimes the procedures you have to perform the test may not allow you to do that. So where do you go with it? And I think Mark's right. We do need to try and get some improved guidance, even if it's not numbers, a framework that would allow us to make a reasonable assessment of how we can do that.
I agree, Melvyn, and I think it's getting that consistency as ever with us. You know, we've seen that recently in the conference. We're all taking different approaches and coming to different conclusions on identical systems. You know, we've got a wealth of experience between us. We shouldn't be having inconsistencies with our decision making. It should be straightforward. And I think, you know, we've just highlighted there in the last 10, 15 minutes that different differences in approaches. And it really shouldn't be that tricky. You know, if you've got a wood dust system like Craig says with a cloth filter, you know, we should have a limit. If they are going to permit companies to use those, what are we saying is okay to come out the end of those next to the operator?
Yeah, I mean, getting back to recirculation, filtration, fume covers again. Often the testers are prohibited by what they're allowed to do as well, because some of the materials that are used for testing filters, recirculation filtration ones, IPA, sulfur dioxide, ammonia, formaldehyde. Some users do not want you to introduce those type of materials into their environment, even if it's in a controlled condition, you know. So, and you can also do tests on recirculation filtration cupboards where the chemicals that you use to test the carbon filtration side are not particularly good for the particulate filter if there's one fitted in there. You know, they can ruin it. And you need to make an assessment. And I still think rather than just give a number, there needs to be a framework that allows the tester to make a reasonable assessment of what those numbers should be. Because at the end of it all of our testing is based on our assessment of that condition. And as Adrian often points out, at that particular moment in time. None of us can guarantee anything once we leave the room, but I think it's the framework that's needed rather than just give precise numbers along the way, a good framework that we can all follow.
Kathryn, did you want to say something?
Yeah, I thought that was all really interesting. Just a couple of things. So, Mike, you seem to be coming at it from the occupational hygiene point of view, which I completely understand. If we did a test with a dust monitor and found 10% of the well coming through the filter, and it was only used for 10 minutes a day, then our recommendations would be the 8-hour exposure limit for that worker was acceptable, and we would be alerting the client that if there was to use it for anything significant, you know, so many hours a day, that they would be starting to have issues in terms of getting close to the acceptable levels. From the other side, from an LEV performance point of view, first of all, I think if you've got a system that's been commissioned and it's got the right type of filtering to start with, that's the first thing. Has it got the right type of filter? Secondly, I think part of what Jane was saying, and I just wanted to clarify this, is that another reason for doing the test as an LEV tester is that if you have a filter that should be performing to a certain level and there is more breakthrough than you would expect, then that, if you leave that system without doing anything about it, the performance is going to reduce over time. You're going to get a reduction in airflows. So I think there's that side of it, that it's indicating that, but it's also giving you some indication of what exposure levels might be. So is are those two of the reasons that we need to be kind of looking at the results from a test at the filter? Does that make sense? Have I kind of understood it correctly from both points of view?
Yeah, I think you're right, Kathryn. I think that if the manufacturer supplies a figure that their system will perform down to, you're quite right. Then yeah, absolutely test against it. And I'm not saying, I think there is a place for testing at the, you know, to see that filters are sited correctly, for example. It gives you an indication, is everything okay? It's indicative, you know, but I think we just have to be so careful defining what and that's exactly right. It's what are you doing the test for? What are you comparing it against? And what are you trying to achieve with those results?
I think. Sorry, Melvyn.
No, go on, carry on.
Oh no, I always bow to you, Melvyn.
I was also going to say that manufacturers don't always just qualify by the type of chemical or material that's going to pass through their filter. They often talk about the frequency of the use and the volumes that are passed through, and quite often with fume cupboard size they talk about the temperatures as well, because all of those can influence how those numbers change. So when they talk about recirculation filtration cupboards, the majority of manufacturers are very good. They ask the user what types of chemicals might you use, what the frequency, and they will design a filter to achieve that. But where it becomes difficult is often when a user will want to change a filter. For instance, the filter fails or is saturated, they don't always revert back to that original supplier. They'll look around for an alternative that might be slightly more competitive or offer or improved conditions, and they fit those filters. But then you're back to trying to make an assessment of, does that filter have the same capabilities as the filters that's been removed? So sometimes it's not straightforward, and the detection capabilities of the equipment that you use and also the process of the test are really important, because just minor changes in those can make a significant difference on the type of numbers that you can measure.
So I think Kathryn made some really good points, and she seems to have exactly understood what I was saying, in that when you're looking at the efficiency and the effectiveness of the filter, you're looking at it for two reasons. I don't want to keep disagreeing with Mark, but personal exposure consists of considerably more than the amount of contaminant that is being returned through the filter, and you cannot possibly take the measurements that you've taken of the dust that's coming back through the filter and say, oh right, it's perfectly okay, this person's personal exposure, which relates to all the things they do during the day, which may or may not be controlled by any LEV at all, let alone effective LEV. You know, it's apples and pears and, you know, horses and donkeys. We're not looking at exactly the same thing. What you're doing is adding a layer of information that feeds into the risk assessment that the client needs to make, and you're giving them some advice. And that advice is often that this is indicative of the performance of the LEV not being quite right. You need to replace the filters. Not replacing the filters is ultimately going to lead to issues further down the line with the LEV, and not replacing them. I mean, maybe the filters are just not fitted correctly. You know, we don't know. Maybe they're poor quality fabric filters where the system was originally supplied with a high quality filter, and they've been on the internet and bought some cheap and nasty Vietnamese or Chinese replacement. Not to be racist about it, but they've bought some cheap imported product to replace it rather than the originally specified product. Because let's face it, most fabric filters and most systems using fabric filters are not supplied with anywhere near the amount of data that they should be in terms of the quality and the qualities of that specific filter, coatings that they've got, how they've been tested. All of that is a huge, great big hole in the LEV industry, which needs to be filled in. But in the meantime, when you're giving the client that information, what you're saying to them is, when that person is stood here downstream of the return air from the LEV, from that single source, this is possibly, and not terribly accurately, likely to be the kind of levels they are exposed to. You cannot relate it to their personal exposure any more than that, because you don't know what else they're doing. It's just part of the big picture that should be part of our everyday life. Sorry, my laptop died and I'm trying to do it on the phone, and I don't know where.
Can I come in there? So I agree with you, Jane. You know, personal air monitoring is different to the effectiveness of a filter, and we don't want to get them confused. They both have their place. They're both important, and they are part of the whole control effectiveness but they're not the same thing. The handheld equipment test is an indicative value to say, we think you might have a problem, you need to go look into it further. It's not a black and white, everything's fine here, there is no exposure to the operator. So we shouldn't confuse the two, and both do have their place in the overall control effectiveness and the control solution. I do think there is an onus which needs to be put back on the manufacturers of recirculating filters. Very, very few of them actually specify what you need to do, when it needs to be changed. They should be saying in their commissioning documents, and we've gone nearly 40 minutes without mentioning commissioning documents, but in the commissioning documents it should specify what we should be looking for when we're testing these systems, and part of that will be, when does the filter need to be changed? Is it done on pressure? Is it done on dust in the air? It should be on, not dust, I say, but what is in the air. And risk assessment. Again, when we go out testing these systems, we should be asking to see the risk assessment, which then should detail when systems are being used, how long they're being used for. So when we're doing that assessment, and it is only being used for an hour a year, which something I was told the other day, or whether it is being used for 12 hours every day, that should be part of the risk assessment. And this is why we need to get those documents and to understand how the system is being used. Okay, that's my bit.
Could I just come in there with, we're talking about manufacturers giving qualification of performance. To the best of my knowledge, I've never seen any manufacturer confirm a compliance requirement for the end user in the as used condition. That I've never seen that on the manufacturer's data. All the manufacturer will tell you do what their equipment does. So you're getting a bit of a catch-22. You can't hold the manufacturer responsible for what the end user is actually doing with the equipment. All you can ask the manufacturer to do is to confirm that the performance that he says or they say their equipment can achieve is achieved. So there is a hand-in-hand situation whereby you have to test for the manufacturer's compliance, which means testing the filters. Then you have to do a separate assessment as to whether the end user's getting the protection, if that's what you want to achieve, because otherwise you can't ask the manufacturer to be responsible for what the end user's doing. They don't accept that responsibility. They only give a qualification on the product performance, not its as-used performance. And as we all know, that's where these things fall down. We need to get a bridge somewhere that allows people to make that assessment. And unless people understand the crucial need to perform an as-installed test on this equipment and then an as-used test, we won't ever achieve those two things.
Melvyn makes a very valid point there. And what I'd like to bring you all back to the fact is that what we're talking about here is part of a Reg 9 examination and test, a thorough examination and test. And we need to look and see what Reg 9 actually says. And Reg 9 relates back to Reg 7. It does not relate back to Reg 6. That's what Reg 10 does. Reg 10 relates back to Reg 6. And to be fair, it would appear from discussions with HSE that in the revision of COSH, which whenever it will come, they've said that they're concerned that Reg 6 and Reg 7 are not tight enough, closely tied together, and that will be addressed in some future. So fair enough. But, it says under Reg 9, the first statement under Reg 9 is that we're doing the testing on systems provided under Reg 7. It then goes on to say what the purpose of the testing is, and it's to ensure that the equipment is in efficient state, efficient working order, good repair, and clean condition. And it states that very, very clearly in the reg. If we go to the approved code of practice, which is pretty tough in the sense that although it's an approved code, it clearly tells us. Now, I'll read it out to you. It says the objective of this regulation is to ensure that every element and that would include the recirculating filters. Every element of a control system, a control measure, beg your pardon, performs as originally intended. Oh, it then goes on to talk about and to identify significant deterioration in any element of the control measure. Now that kind of ties back into what Melvyn was saying, that manufacturers don't give us what the intended performance should be, expected to be on recirculating filters in many cases. But we must tie it back to the fact that currently the legislation for Reg 9 examination and test ties back to Reg 7. And it's talking about looking at the elements to see if they are performing as originally intended, and indeed if there has been any deterioration. So that should maybe help to focus us down on what we ought to be doing with recirculating filters. To do nothing is not an option, but I think it's good to open it up to say, what are the options? My pennyworth is that what you do in a recirculating filter, to some extent, is going to go back to Reg 6, having just said that Reg 6 is not really part of it, it's Reg 7. But to some extent, we have to look at the risk and the degree of testing or the protocol that you would use for testing recirculating filter has to have recognition of what the risks are. So it may not be that there's one size fits all. There'll be different types of testing levels, if you like, depending on the risk. Okay, I'm going to shut up now and let. What I'd like to hear is there's 3 or 4 of us doing a lot of discussion, and there's 27 on the unit. I'd really like to hear a lot more from you guys who are a little bit quiet, because your views are every bit as valid as some of us more verbal people. So if anybody else that hasn't chipped in would like to say something, I personally would love to hear what other people think. Oh, well, that didn't work.
Hi, Bill. It's Kenneth here. Can you hear me?
We can all hear you very well,
Yes.
Kenneth. You carry on.
I don't know, and I'm listening and using the kind of term reasonable assumptions, which is in some way what we'll have to do. Is there scope for even a series of, I'm thinking like the HSE sheets on processes and kind of recommendations for control? Really, an ideal thing would be a worksheet or some sort of information sheet for testers, for wood dust systems. Okay, what are reasonable filter efficiencies for needle felt filters? What should we be looking at for testing? Because it's also different for each type of system. Melvyn's talking about recirculation, fume cupboards, we've got wood dust, we've got weld system. The 2 biggies quite often in testing are welding and wood dust. You know, is a scope of us coming together to form like some information sheets for what a tester can reasonably look at when they go to a wood dust system? And Jane's points, okay, about, you know, what am I measuring and what does that mean? Can I make a reasonable assumption from that? Or if it's a weld fume system, what type of filters do I need? You know, I think there's a lack of understanding in the industry about filter classifications, particularly at the people who are going out testing. You know, some worksheets on the filter classifications. What can I reasonably expect when I go to see a welding system, if they're welding mild steel or stainless? And what does it mean when I measure something? And then what reasonable assumptions can I put back? Because it's going back to the LEWICKI conference and all the questions we're all answering, and there's such a mix of answers. You know, could we say, okay, well, here's, you know, whether it's LEWI's, you know, opinion or LEV Central's, or a mixture of us saying, here are some guidelines which we think are reasonable and everyone could work to. And even starting off with one worksheet, say, let's take wood dust and put it out there and see, how does this look? Is it something which we could reasonably then take to weld fume, to recirculating fume cupboards, to solder, you know, over time, have a series of information sheets which people could work to?
I will hop in here. I'm sorry, Bill, but there's a bit of background information that you probably none of you, other than maybe Dean, are aware of. So, Kenneth, I entirely agree with you. You're absolutely right. What some of you are not aware of is that the information isn't available to the manufacturers. This actually goes right back in a loop to the manufacturers of the filter fabric, who provide absolutely no information about the effectiveness of their filter fabric. They'll tell you what sort of coating they've put on it. They'll tell you how thick it is. But there is no, and they'll also quote various standards, most of which, you know, are complete bollocks, to be perfectly honest with you. When you actually start digging into it, you know, the whole filtration industry is full of waffle bollocks. And that is exactly what it is. I've been spending quite a lot of time as LEWICKI, working with the HSE on identifying what the issues are. And we've come to the conclusion that, yes, what Kenneth is asking for is what we're all crying out for. But before we get there, we need effective, simple test procedures, repeatable test procedures for the fabric, standards for the fabric. Then you need simple standard test procedures for that fabric fitted to the manufacturer's equipment in a factory in test circumstances. So we can say, these are the exact properties and standard of this fabric. This is how it performs in factory conditions, which are not real. And then we can say, this is how it should perform under load, under duty, in the workshops of people's clients. And this is the labelling and the standard that you should be looking for on the filter fabric that has been used. These are the standards and the tests that should have been subjected to before being turned into a wood waste filter on a unit. And this is what you should be looking for and testing for on site. And one of the thoughts that the HSE have expressed to me that I think will be included when they finalise it, and they've agreed, they've been through all the standards that everybody has said, well, this standard is quoted and that standard is quoted, and they've come back and said none of these standards are fit for purpose for this type of filter. People are trying to fit them to this type of filter and saying, does it comply with this standard or that standard? But they're just not relevant, they don't work. So new standards are required and they're working on them. I'm losing my thread now, so I'm going to let somebody else pop in. The last thing I want to say is that within the education sector, testing of fume cupboards, the on-site saturation testing and testing of the filters in fume cupboards in schools got stopped because of all of the difficulties in performing it. And that was replaced with a regime recommended by CLEAPS and endorsed by the HSE of changing recirculatory filters on educational style fume cupboards according to a strict calendar depending on where they were situated, so whether they were in the classroom or perhaps in a prep room, and which chemicals they were being used with. And they require those filters to be labelled, not with hours of use, which is interesting, coming back to our discussions earlier with Mark and half an hour a week and what have you. What the HSE and CLEAPS decided was all of these filters should be labelled when they're put in with the date they were put in and a date they need to be changed by. And those dates are specified. They're 6 months, 12 months and 2 years, depending on exactly what they're being used for, and whoever is changing the filter needs to label it accordingly. And I think we're going to end up with something like that, something that says for welding, for woodwork, this filter should meet this standard when it's fitted, and regardless of the use, which is quite an onerous thing for them to say, but is it less onerous to say you must change a wood waste filter every 12 months than to say whoever's testing it must have a look at exactly what is passing through the filter and coming back in? And my experience is that depending on use, a wood waste fabric filter can be fine from anywhere for 12 months to 15, 16 years. You know, if they're really only using it for 5 minutes a month, it's perfectly fine. You know, I've tested lots of them that are perfectly adequate 15, 16 years later. And our recommendation would always be, well, this is well past its usual life. We suggest that you change it. But nonetheless, it's still working fairly effectively, and you don't know when it's going to fail. But I'm happy to answer any questions on the current HSE iLEVI project on recirculatory filters, which I chair, which is how come I've got a certain amount of knowledge as to what's going on behind the scenes that maybe the rest of you are not really au fait with at the moment. And I promise not to talk for at least 5 minutes.
Go on, Dean. I think you've had your hand up longest.
Yeah, I was just going to say, James referred to well, it's not just iLEVI. There's many of the industry people involved with the Industry and Regulatory Forum of LEV, which is having a big discussion now on recirculating filters. And Jane has been a big part of it, as she said. And we've tried to have a meeting outside of that. So if anybody does want to come and give us give their opinions, please do so. Get in touch with myself, Adrian, or Jane. But the other thing that we're looking at doing from iLEVI is very much what we were talking about before, direct reading instruments. And there's a lot to be said about it, but the big thing is, how are they used? What do you get out of them? Because you've got to take into account things like humidity, temperature, what the substances are. So you are limited in a direct reading instrument, but at least it gives you an indicative point, and it can lead to recommendations. So we're looking also at coming up with something on how to use these test instruments, and we've obviously got the BOHS involved in that, because you need occupational hygienists involved with that. But it's another thing that I'm opening up to the floor now. If anybody on this call wishes to be involved with that, to put their 2 pence in or more, please get back in touch with me. That's really what I wanted to say. But as I say, Jane is heading up the recirc filters of iLEVI and other bodies who are involved. If you want to get more information, Jane is definitely more involved with it than I am. Okay, thank you.
Melvyn, do you want to go next?
Yeah, if you look at manufacturers' requirements, the standards that they work to are really just to encourage international trade and communication. They're not there for safety reasons. So the manufacturer obviously takes safety into consideration, but that's not the primary reason that these standards are written and they perform to a standard. It's to encourage international trade and allow communication. And the standards generally have always the same format. There'll be materials, they'll have dimension tolerances, the performance that the equipment may have to achieve. It will tell you how to do sampling. It will then give you a list of test procedures that the manufacturer will follow to prove compliance with the standard, not with the end use of the device. It's to provide compliance with the standard. Now, where it becomes difficult when you start talking about recirculation filtration equipment is there's never ever going to be two situations that are identical. There will never ever be two assessors that will make the same determination of that particular site installation and its use. So it becomes even more difficult when you get the substances they're using. Now, because of Kosh saying that if anything has got like a cancerous undertone, you have to get it down to as low as reasonably practical. You then get into the situation that the assessor may decide on a number that is so low that it can't be detected with the equipment that's detailed in the standard that the manufacturer has used. So it's not always easy just to write an end number and then relate that back to the filtration capabilities of a filter, particularly as most of these filter tests are done in, as I say, intrinsic conditions. They're done in an environment where there is no other interactions or other interferences. It's always easier to get the performance criteria more detailed than in the site installation, because you can actually tweak all of the performance criteria of everything else in the room to suit the test. You can't always do that on site. So I'm not sure whether we're ever going to get to where you can give an exact number that everyone will be able to follow. Again, I think we may have to settle for numbers within a framework that could be deemed acceptable, rather than just say it must be less than 10 or it can't be any more than 5. You know, I don't think we'll get that situation.
Just talking about manufacturers, I just want to relay an experience I've had recently of buying a H13 HEPA filter from a supplier who claims it was H13, and yet when we tested it, we found out it was absolutely useless and might as well not have been there. The supporting evidence they provided us was from the material provider, which was based on a flat sheet of material. And when they create it into manufacture into a HEPA filter, they pleat it. And when they pleat the flat sheets, it does that. It breaks. And down the pleats, we were getting basically particulate coming straight through, because there's virtually no filter there at all. It only takes a pinhole in a HEPA filter to make it ineffective. So you just need to be very wary of some of the claims you get from manufacturers. They will say this material is good for whatever it is, but once they've manufactured it into their filter, that will change its dynamics. When you then install it into a plant, if it gets dropped, bumped, knocked, damaged in any sort of way, that will make it ineffective. So just as a word of caution, really, don't always believe what you see written on the manufacturer's literature. It may be correct, as Melvyn was saying, for the product they started out with, but it isn't always the same thing you get on site, which you are then testing. So it's don't always believe what you see. Okay.
For me, I think it's difficult because I've come across this a couple of times in site installations. Like there was some testing being done on some microbiological safety cabinets, and the tester was following exactly the instructions that was in the manual of the piece of test equipment that he was using, which was a potassium iodide Chi-discus equipment. But what he was finding was, as he moved from one device to another, he was getting higher readings. But what he was getting was cross-contamination, where he hadn't cleaned the equipment when he took it from one device to another one. Now, when you read the manual for the Chi-discus at that time, what it actually told the tester to do was to clean the equipment at the end of his testing. Well, if somebody starts in the morning and they work to the evening, they've not finished their testing if they move from one piece of equipment to another. So I'm always slightly hesitant to criticise manufacturers too much if the procedures that a tester has used are either not in accordance with what the manufacturer has used, or could be influenced by other conditions that would not be present in the manufacturer's installation in a type test room. Now, I'm not a manufacturer, so I'm not defending manufacturers. I'm just trying to relate to, sometimes it's not always a black and white situation that somebody is right and wrong. There are sometimes detection levels of equipment can be different. The worst thing for me is when people make claims. People make claims for compliance with certain standards, and then quite obviously they're not achieving them. Now that does two things. One, it weakens the confidence in the standard that they're claiming compliance with, because people start to question whether that's wrong or they're wrong. And then you get the situation where you're left with a client who's got a manufactured product that tells you it has to perform to this level, and you're saying it doesn't. And they're saying, well, how do I prove that back to the manufacturer? So it's not an easy situation, and I hope that whatever work LEWICKI are doing can at least give people an opportunity to make challenges that people will work together to try and find an end result to, and not set up walls, because I think that's the problem. If you challenge a manufacturer, the wall goes up immediately and you don't get anywhere.
I actually wasted a whole week of my life contacting every single manufacturer of wood waste extraction equipment in the UK, asking them on behalf of LEWICKI what evidence they had or what documentation they had around their filters. Some didn't reply. Those that didn't reply, I rang them up and explained again why I needed it. And in the end, most of them did communicate with me on some level or other, and nobody was able to provide me with what I would have regarded as good evidence for what they were doing or what they were saying about their equipment. Those that did provide evidence, you know, when I tracked it down and I looked at what they were giving me and the standards that they were quoting, they were completely inappropriate. There's no way that they had tested their filters to that. You know, they were just picking numbers up off the internet. That's the honest truth. There's a huge amount of unscrupulousness within our industry where people will say what somebody wants to hear, and if they're asked to quote what standard they're working to, you know, my professional opinion is 95% of them make it up and the other 5% say no idea. But when you actually spend time looking at the documentation, tracing it back, they're quoting standards that don't exist. They're quoting standards that you cannot possibly use for this kind of equipment. And that the whole industry needs a huge shake-up, and it has to start with the fabric or the filter media and testing that is appropriate for the kind of systems they're fitted to, and then that can evolve into the kind of testing that you do on site and the kind of guidance that we all want. But in the meantime, direct reading instruments have a role to play.
What I would say is just going back to something Adrian mentioned earlier, and it's commissioning reports. So I think that's the point at which we need to be defining a level that we say, well, we've tested this, we're happy with the system at this level, at the filter, this is what we get today. That's when you benchmark it and say, you know, that. So it goes back to what you were saying earlier, Jane, which I wasn't totally disagreeing with, was that there is a place, but I think we have to be very careful in defining it. And this is my issue, that there's just, we're seeing a lot of figures put down on reports that are not related to anything. And I think in the absence of any of these guidance notes or manufacturers provided information, I think it's probably back to us to introduce this figure with a definition within the commissioning or initial inspection and say, right, this is what we use going forward, and here's why we're using this figure, you know, with a reasoned argument for what we're putting forward there. Be great to hear, as Bill said earlier, be great to hear from some of the others on the call today, particularly if we've got any manufacturers and their view and what they do.
I've done quite a bit of type testing in my years for manufacturers, and I think the thing that saddens me the most is that I would say 90% of all the cases, they never ever read the report I gave them. They never read it. They never asked any questions about it. I always used to say to them afterwards, I've just given you a 48-page report. That's the typical report for a BSEN 14175 cupboard, 48 pages. And I said, I've just given you a 48-page report. Do you have any questions? And nearly always, they always ask the same thing. Do I get a certificate that says it passed? As soon as they get that certificate, that's like the golden wand. They don't ask anything else. And I had an incident recently, and I was asked to look at some BSEN 14175 type test reports. And when I started reading the reports, I was so shocked that this report that I had, the velocity tests at the beginning were done on a cupboard that was 1200 wide, and the containment tests, which was at the back end of the report, was on a cupboard that was 1500 wide. And it was for one cupboard. And I rang the manufacturer and I said, you report you've got velocity tests on a 1200 cupboard and you've got containment tests on a 1500 cupboard. Why is that? And they said, I don't know. Are you sure? And I said, well, look, I've worked it back, all the containment factors, all the volume flows, definitely 2 different cupboards. When he rang up this test house that had done this test for him, I don't know, 8 or 10 years ago, they said to him that they'd tested 2 cupboards at his establishment, and when they put all the results in a folder, they'd taken the velocity results and they'd mixed the 2 up. Now this type test report had supposedly been circulating for 8 years and nobody had noticed it. So going back to what Jane was saying, I can really understand it. The manufacturers do not always understand the technical implications of the reports. They're interested in the commercial advantages that the report gives them. So they will often take the word of the test house and they will just use it. They won't understand whether it complies with the standard. All they will know is they've got a certificate that says it does. So Jane made a really good point. Manufacturers are not always trying to mislead. Many of them don't really understand what's needed. And I think if we can get manufacturers a bit more on board and say that we're not out to try and defeat them or work against them, it would help us and them if we had some sort of common unity that allowed us all to operate within a given framework and be giving out good advice. It would suit the manufacturers, it would suit the test houses, and both of those would in turn suit the end client, because you would be able to come up with some of the numbers that Mark is trying to achieve. We would be able to come up with some numbers.
Can you hear me?
Sorry.
No, you carry on, Kathryn.
I was just going to jump in there and say that with an occupational hygiene hat on, if we were working with a client and we were giving them advice and good practice, particularly if they had hazards that should be ALARP, we would recommend to them that they purchase their own monitoring equipment and that they keep records of the date of the filter change and then the test results from their direct readings at the filter on a regular basis. And then when we went to do the LEV test, we would be able to see the logbook, and over time you can then see a pattern. Filters changed on this date, the readings start to get affected by this time, and then the filters changed again. And over time you start to build up a good picture of how that filter performs against your production, you know, the amount of production that you do. And if your production increases, you can then look at how your readings change. That's obviously ideal world, but particularly with blue chip clients or big clients that, you know, should be able to invest in this type of work, I do think it's something that they should be doing in-house. And as an LEV tester, it'd be really nice if we went along and saw logbooks that gave us that type of information.
It'd be just nice if we saw logbooks, Kathryn.
Very true.
What I was going to say is there's a big problem in the industry, in all industries, particularly education, where they're saturated with existing recirculating units, and the manufacturers would have long washed their hands of those and not care about them. And most of these have never had the doors off in an LEV test. And I know we can argue that's not a thorough examination test, but when you get there to get the doors off, the clean side is packed full of wood dust. You know, they're failures. We've got a real big problem with this. And this goes back to what Kenneth says. We need some standards. We need LEV testers particularly to look a bit more closely at these.
One of the things, Kathryn, that I've come across quite commonly is that, particularly in education, that they're focused on teaching, and their teaching is what's important, getting through the curriculum and getting things done. So they tend to use advisors to be steering them, or they follow certain codes of practice. Now, in education, we have, I would say, 95% of all the UK education establishments are influenced by the work of CLEAPs. CLEAPs give work to DT shops, they give laboratories, they give metal workshops. All that advice is generated through CLEAPS. CLEAPS give them documentation on good procedures, good practices, what they should be looking for. So perhaps we could try and implement some of the work that CLEAPS does, because I know CLEAPS are open to communicating more now. That there is a different regime in CLEAPS to what there used to be. In the 70s and 80s, they were very insular. That they felt that all manufacturers or testers their sole objective was to charge the school a lot of money for little or poor advice. So they were very protective of them. But there is definitely a new regime at CLEAPS now, and they are far more open to listen. But I'm not saying they're going to change everything overnight, but they are acknowledging that there are other people outside of CLEAPS that might be able to help them. I went on a course with CLEAPS last week, a fume cupboard testing course, just so I could try and get an understanding of how they teach. And what I came away with was it's very, very 60s and 70s. Even the course they're teaching now, it's very 60s and 70s. And when you think of all the technology and all the information, all the advice that's available to CLEAPS outside, that they could do so much more. They could do so much more for themselves and the people that they support, the schools. So what I hope may happen is that people like LEV will try and engage more with CLEAPS and just try and find some common ground, because I know there's some old history with CLEAPS and how they've been, but I definitely feel that they've got a slightly different approach, and I for one would like to try and see if we can work with them, because if we can influence CLEAPS, they will influence the education people, and that market then will be improved for everybody.
Can I ask the question, has anyone ever approached a manufacturer of a recirculating system and asked the question how they propose to measure the gases and things that could pass through the particulate filter? Has anyone asked the question?
I raised that question with a manufacturer on LinkedIn the other week, Craig, and they didn't understand the question. They didn't think that any gases came through. They didn't quite put it as simple as that. The answer is a lot more aggressive.
I wasted a week of my life, as I said earlier, a whole week, Monday to Friday, all day long, doing nothing but contacting manufacturers of recirculatory LEV of all types to ask them about their filters, how they recommended they were tested, how efficient they were, how effective they were, how do they know that, what testing's been done, what data sheets can they provide, what technical information have they got. And I provided evidence I was asking on behalf of LEV and the HSE for a project that we were doing into it. And, you know, 95% of them tell big fat porkies, and 5% of them don't even understand the question. You know, those that do understand the question think, oh, I'm being asked for a technical document, I'll make something up. I went to the people that actually make the fabric, the people who import the fabric, and other types of media. You know, it was, I say it was a waste of a week. It was an informative week, because it just confirmed my prejudices that there is a huge hole in the technical data that is available to us. And that's where we need to start. We need to get that sorted first.
I would also like to reflect on what Melvyn and Jane said in the past regarding the real-time equipment and assessing the efficiency of the filters. I think also HSC admit the fact that, for example, from my experience when I've been looking to the efficiency of the on-torch extraction system, there is a little margin when the fumes are not always fully captured, and that will depend on the position of welding and other aspects. So what happens then, there is a certain amount of contaminant that is actually getting airborne, and that's obviously going to be mixed with the general atmosphere. So being in a position of using real-time monitors, how are we where are we placing ourselves in a position to actually determine the efficiency of the filter, taking into consideration the airborne contaminants? So where is that proportion of where the contaminant is actually coming from the source and not rather than filter? So as Melvyn said in the past, as long as we've got a fixed number, I think, and as long as we've got a method of actually testing the filter like they do with the biosafety cabinets, testing the efficiency of the HEPA filters outside of the unit, I don't think we'll find ourselves in a comfortable position to be 100% certain to say yes, the filter is actually effective or not.
Just to come in on that, quite often it's difficult to determine whether the filter is letting by or whether it's the seal of the filter that's letting by. Because if you call a manufacturer and say the filter is letting by, they'll say to you, does it have an effective seal? And you have to try and do a seal test. Now I know they use perchlorethylene in G9, in the Cleaps G9, to do a seal test, but sometimes it's not always easy to determine whether it's the seal that's letting it through or the filter. So I don't know, I just feel slightly anxious that you may not get an exact answer from a manufacturer, yes or no. But Jane is right. Most manufacturers bundle together as many BS and EN numbers as they can find that they think their equipment complies with, and they put that into their literature. And in many instances, they've not even read them to see whether they do. But it's a marketing tool. People read it. I mean, I had one recently where a manufacturer put on the market a new nano chamber, and it was a device that was claimed to be used for nano materials, and it was, for all intents and purposes, it was a Class 2 microbiological safety cabinet, but it had an air curtain that ran down the front of the cabinet. But then they listed in there that this cabinet exceeded all the requirements of EN 14175. Now, when I asked them the questions, they wrote back, and 9 questions, they wrote back and said to everyone, no, we didn't test it for that. But they said it exceeded the requirements of it. Now, EN 14175 has no relevance to what this equipment was designed for, but what it does do, it attracts someone's attention, because EN 14175 is an established standard. People see the number and they get comfort from thinking that this device is superior to what is already known to be a very good testing standard. So Jane is right. You know, manufacturers do have to try and step up to the plate, and not just give out advice, but give out advice that can be backed up.
If I can just come back in there, I mentioned earlier the Industry and Regulatory Forum on LEV. Something which is coming out of the last meeting that was had is there's going to be workshops, HSE workshops in October, and it'll cover 3 themes: filter and device standards, commissioning and thorough examination and testing, and monitoring and alarms. And basically, they'll be involving people from the LEV manufacturers, LEV test and commissioning engineers, and the filter manufacturers and duty holders, and getting them to do, it'll be a full day workshop. And the one, as I say, is the filter and device standards, which would be what works well, what doesn't, where are the gaps, that sort of thing. Monitoring alarms, what is the most practical monitoring? It's very practical, and it's got these in. So hopefully we'll be getting a lot more feedback from that as well later in the year.
Dean, can I ask what forum was that on, please?
It's the Industry and Regulatory Forum on LEV. iLEVI initiated it, and HSE have pretty much taken over it, but that involves people such as BOHS, let me just make sure I get the right one, BOHS, IOSH, SAFED, BISA, ANITA, UCAS, FETA, SHAPA, obviously the HSE. So there's quite a forum across the industry involved with that. Oh, and the unions involved as well, Unite.
Dean, that's the same forum that came up with the, or helped to develop the training matrix, I think, isn't it?
Yep, that's where that came from. And Adrian's nodding his head. It's still being developed because there's changes going on, and at the moment Melvyn is involved with the next section of it on fume cupboards, recirculating fume cupboards, and that side of it. Once that committee is finished its deliberations, we'll feed back that into the competency matrix, and that will become part of that as well.
I think one of the things that I hope we might achieve is to try and engage more with manufacturers and users so that we can perhaps assist them in understanding standards. I mean, there are some things written in standards that people just take for granted. There's a new standard being drafted for recirculation filtration fume cupboards, and in that standard they ask you to put a challenge of 200 ppm of IPA inside the cabinet and test for 1% of an OEL outside. And they use 16 sensors across the top of the filter to determine whether there is any leakage. And yet, on that same cabinet, in that same standard, they say if you have a device that's used to monitor that particular filter, i.e. a sensor, a vapor sensor, when you test the vapor sensor, you only use 2 ppm of IPA. Now, for me, if this is the device that's going to be monitoring that filter, what are they relying on? They use a challenge of 200 ppm when they do the type test, and yet they're saying when you do the field test, provided you're doing it in 2 ppm and you're getting the value, that's good enough. Well, if 2 ppm is good enough for the sensor in the field, for me, why don't they use 2 ppm in the type test? It's getting to understand what these standards mean, because just having a monitor on something doesn't mean to say you're safe. Does that monitor actually do anything credible for you in assuring you that that filter is performing its role? If it doesn't, take the thing off. Why have it? For me, a monitor serves a purpose. It alerts somebody if there's a problem or indicates that a control condition is being maintained. If you're allowing monitors and sensors to work at levels lower than what you tested them at for performance of the equipment, why do you have it? What is the need for it? We need some sort of common sense in what people read in standards. And if they don't achieve it, we should be saying so and ask for them to be removed. If I may, it's a bit different to recirculation filtration fume cupboards, but there's shortly due to be a standard being issued for public comment, and it's a standard on articulated extract arms, which you all use in some shape or form or test. I would like anyone who's interested to comment on that to drop me a line, because I'm going to try and see if I can circulate that to you. The standard is called PREN 16589, and it's the standard that covers laboratory articulated extract arms, which are more or less exactly the same as what you see in welding environments, and they are on ducted systems, recirculated systems, and that's due to come out for comment. And as Adrian has said and Dean has said, we need people other than the same faces and voices giving some opinions, and I'm happy to take your opinions back to the BSI panel so that they're getting a broader view of some of these standards. For me, the guys that are given these standards to use, they're not getting enough say in what these standards contain. So I would hope that now people will make comments so we can try and get this into the standards before they're issued for use.
Can I just bring it back to the original measurement that we're discussing? And I think we're all in agreement there is a place for the measurements, but I think, can we just agree that if we're defining it on an LEV report, that we call it something like baseline figure? You know, if you're doing a reading at the filter, so that we can see going back through the history of the report, you know, what it was and who took it and why it took. Is there anything we can add, do you think, on an LEV report that defines that and pinpoints that as the initial figure in the absence of a commissioning report, if you're adding it into a routine inspection, for example? Just so we're all trying to get a little bit of consistency with these readings.
I think I would only call it a baseline figure if I was taking the test when the filter was reasonably new. Because if you go to an LEV system and you do a test and you've no idea how old the filter is or any issues they've had with it, then I think there needs to be some context put in the report about when you're taking the reading and the conditions under when you're taking it. But I think if I was to call it a baseline, I would want to know that it was just after a filter change.
Would it not be more practical to do that nearer the end of the life of the filter when you know it's at its worst, or at that point of degradation where it needs replacing? So if it was at that level, you know, yeah, way past it, rather than as soon as you put that new filter in, that's at its premium efficiency. Well, until it's coated, obviously. But I think if we're doing something like that, when it's first installed, is not the time to do that base test. It would be not before the filter's failed, but at a time when it has been well used, shall we say.
So I think what we're talking about is adding context to this figure. So we need to have some sort of context rather than just having a figure in a report. It needs a bit of context with the filter condition, what was going on. And I think that's what, you know, certainly I'd like to see a little bit more of in some of these reports. So they have got a bit more meaning than just a figure at a point in time.
Yeah, I think even if you put that you don't know, it's better than just leaving a figure with no context at all. I think doing a test when the filter's been changed is at least telling it that the filter is efficient and doing the job it's supposed to do. I think having a reading when the filter is really dirty or old is great as well, because you can also see, and back to that idea of kind of trying to get a pattern. Ideally, you would have a pattern throughout the filter's life of the breakthrough. But that isn't always possible. So if we're just going once a year and we just have one reading to take, then it's only really useful for anybody else reading that report if there is some context to that figure. That's
context is what we need, you know, Kathryn, context is what we need for virtually everything on the report. You know, ideally there'll be a commissioning report that gives you some really good hard evidence and truthful stuff that you can trace back regarding the standard of the filter and how it should be performing. And then there should be a commissioning report that gives you some readings and tells you what the concentration was, but also tells you that commissioning was done, you know, the day after the plant was installed, or they've waited a month for the filters to develop an effective filtration coat. Whatever numbers you've got on your report, they need context. And you are supposed to carry out an LEV test when you change the filters to prove the effectiveness of your repairs. So, you know, you should be able to demonstrate to your client the before and after that the new filters has made. And that's really worthwhile, not just to justify the fact that you're charging them for changing the filters, but for them to understand, you know, yes, the filters do play a crucial role. A lot of this is about illustrating things and communicating them to the end user and the client so that they appreciate the importance of keeping their kit in good, clean, effective condition, because a lot of them just think it sits in the corner and it eats dust. I don't know where they think it goes, because, you know, I'm not sure if it was you, Kathryn, or somebody else who was talking about, you know, going to a school and opening the doors and, you know, having to, I think it, you know, you have to lever off the doors sometimes. They're so jammed shut and caked up with stuff. We need to concentrate very much on communicating how important it is to the client and the end user, and ensuring that they know what to look for and what to check, and how important it is that it's working effectively. We've gone off talking about the controls and the alarms that could be fitted. So, you know, whilst it's handy if you've got a client who can invest in the equipment to regularly check, surely it's better for them to spend £100 or so and have some gauges fitted, along with some posters that explain what those gauges mean and a little bit of staff training, so that when the concentration or the intensity of use changes or the personnel change, it's very clearly communicated to people whether or not that LEV is still functioning. It's like anything, like any problem, it needs a mixture of solutions to be implemented, all with equal weight, I think, to enable the end user, the worker, to be fully protected. But controls and alarms have a really big part to play in this, and they're not expensive.
Could I just ask if Louise is able to give us any feedback on the dust monitor that she spoke about, I think in one of the messages. It seemed like quite a cheap device compared to the Cassells or the dust tracks. So I just wondered how that had been faring in the field.
It actually fares really well, and it comes in useful because it's got such big figures. If the filters have failed, like in the thousands, you show the client and they're like, oh God, yeah, we've got to do something about it now. I mean, you take the doors off and show them all the dust and say, well, that shouldn't be there on your clean side. They don't seem to grasp that it's bad for their health. But if you show them, you know, well, you're reading 10,000 parts per million coming out there, you really have got a problem. They seem to panic with that figure. So I tend to give the piece of kit to the client and say, pop that on your outlet and just see what it's doing. And it does work a treat. It's a really useful piece of kit. And I only use it as an indicative figure, but more really to scare them into doing something about it and changing the filters.
So is it something that you leave with the client, or is it a piece of equipment you use and take with you to your LEV tests?
I use it as part of an LEV assessment, particularly in schools, particularly in new builds, I should say, where heat retainment is quite important. You have all these underbench dust filters in schools serving woodworking processes like fret saws and desanders, and they fail in 12 months. They're poorly made, the filtration isn't the right grade or standard, and nobody takes the doors off to check. So you go in for your LEV tests and it's an absolute mess. And with schools, they've got no money, they've got no inkling of what it's doing to their health, they're not really interested. And so if you go the next year, you find the same problem again. So I tend to use that tester to kind of scare them into compliance and say, look, you've got to change your filters. And then when they see those big figures, they generally find the money to do the maintenance that they should be doing in the first place.
I would like to just touch on what Mark Armstrong has done. In some of his reports I've noticed recently, Mark's introduced a clause that talks about operator training and operator influence on the equipment. I think that would be a valuable thing to start getting in our text reports, because I've noticed a few universities are now introducing standard training for their operatives, even over short terms, where an operative, before they can use a fume cupboard, has to undergo basic training in which it's explained to them what the device does, how it protects them, things that they can do to challenge the performance. Also, going on to what Joan was saying, it also explained about the controls and monitors that are there to assist them. So I think if we try to see if we can engage with some of these people to help influence them to improve training and emphasise how important training is, particularly with recirculation filtration filters. If you look at the CLEAT's guidance, they recommend anything from 95% efficient up to 99.9% efficient. That's quite a big margin. When somebody says, well, do I need it to be 99.9 or do I need it to be 95? CLEAPs qualify theirs by saying if you're using certain chemicals in certain quantities, 95 is okay. But others, you need 99. But often users are wheeled into a room, given the device and saying, here's your fume cupboard, here's your class, carry on. They're not always given the time to introduce them to the equipment for them to understand how they interact with it. So again, I think it's for us to try and see whether we can engage a bit more with them to see if we can influence them.
But I think equally, I think you're right on the training there, Melvyn, but I think equally that can apply to LEV testers too. I mean, testing filters isn't really covered in that much detail in the P601. There isn't the opportunity to do that much in a week's training. So it almost needs its own training module, training course itself, I think, personally. I don't know what everybody else thinks.
See, James already explained that CLEAPs have taken a bit of a shortcut with theirs. They've decided that perhaps they should not really be telling schools to test the filters and change them. They should use this calendar period of, if it's in a just a standard low-level use lab, 4 years is okay. If it's in a lab where it's got slightly higher use, 3 years and change the filter. If it's in a prep room, 2 years and change the filter. A prep room where there's a lot of dispensing and changing of chemicals before lessons and curriculums, every year. So some people find a different way of trying to work with it. Rather than do the testing, they say, well, let's change it. Because, you know, sometimes performing a test on a filter can be just as expensive as buying a new filter.
Yeah, and it simplifies it for people as well.
Yeah, you know, but the people that are most affected by it don't always have the power to change anything. It tends to be handled by others. You know, you get estate bursars who decide when and where something can be tested. I mean, there's a ridiculous situation in education where schools actually share anemometers between schools, where you get a school will drive 5 miles across town with an anemometer that they're sharing with another school. And you think to yourself, crikey, these things are 300 or 400 quid. Why don't they just buy one for themselves? The things that could happen in that 4 mile drive would make you think, let's just buy one. But when you're looking down a list of costs and charges, when you tell somebody you're going to get somebody come in and test their filter and it might cost you 500 or 600 quid, and they say, well, how much is a new filter? 500 quid, let's buy a new filter. Plug it in and we'll get going with it. What they forget is you still need the new filter tested once it's in. It's not just buying that filter and fitting it. That filter needs to be evaluated to make sure that it is providing, you know, the performance that's necessary. The bursar doesn't know that. He buys the new filter, then somebody says to him, oh, by the way, bursar, you now need to get the test company in to test it. And he says, crikey, I could have done that to start with. I might not have had to buy the new filter. You know, it looks as if the industry is trying to make money out of the school all the time. Sell them the filter, then tell them they need the test. So I think it's a lot of bridge building along the way. We've got to try and convince them that our interests are pure, that we really, it's their safety. And okay, some of us still make a living out of doing it. That's not an argument. But if we weren't there, who would do it for them?
Melvyn, sorry to interrupt. Rob, you had your hand up. Do you want to come back and have your say?
2 seconds. Sorry, just unmuting. Hi all. Yeah, no, it was just when Louise mentioned about separate training. It has been discussed with the BOHS. I think there is a possibility of a specific filter course being developed, but very early stages, literally an informal discussion. So I think you just have to watch the space for that one.
I think it was brought up on the BOHS conference stream that something like a P605, more of a technical training course, I think would be a great idea. I think that'd be
that's exactly it. So that was all.
Thanks, Rob. I just want to chip in and say, you know, when we are looking at recirculating filters, handheld equipment does have its limitations in that it depends on where you're holding it. When you're dispersing the air from a unit into a room, the air can travel quite some distance. So I think handheld literally is just an indicative number. We really should be doing static monitoring in the room, looking at where the dust or where the contaminant settles, where it falls out, where it travels, and almost doing like a heat map of the area to say if you stand this close to this filter, you could potentially have this exposure. But again, this will come through on a course. Or what I would like to see personally is a guidance. I mean, someone mentioned guidance document earlier, a simple guidance document on how to test. So we're all doing it to the same standard. And that way you can show your bursars, you can show your purse string holders. It's not me saying this. This is what the industry guidance says we should be doing. And if it is a case of we all stand there and hold a handheld meter 1 meter from the unit, then so be it. If it is, we have to put 4 or 5 sampling pumps out on various radiuses or distances from the source, then that's what it is. But I think if we have that guidance, then we have that level playing field, and at least we can all work to the same standard. And then from that, we can, depending on what the results are, we can then, you know, develop other things.
That guidance is one of the outcomes that will come from the committee that is looking at this with the HSC. I do need to duck out because I've got something else that I should be doing. I just wanted to give you the informal feedback that I've had from the HSC while we've been discussing this. And the first thing is they like handheld direct reading instruments. They like them. They think they have a place. They're not going to give you an actual value. They're going to give you an indicative value as to whether or not you need to take some further steps, get some more information, and whether or not there is likely to be a problem, or on the balance of probabilities, there isn't a problem. They're very keen on them. They're doing some work on very cheap handheld devices and more expensive ones, and deciding whether or not the results that they get are repeatable, and whether or not you need to spend £2,000 or £3,000 on an instrument, or whether one of these cheaper instruments that's just a few £100 is reliable. Now, the information they had the last time I spoke to them about this was that they have been doing a lot of research. They've been testing them. They will be publishing a report. Like all HSC reports, these take ages to be drafted and approved and to be released. So I wouldn't expect to see it land in our inboxes anytime soon, but the work is underway. Some of the very cheap devices they've tested are not reliable. Some of the more expensive devices are very reliable. They're trying to decide exactly, you know, where it is that you need to go in terms of reliability that is just enough. As an organisation, I provide all my engineers with a Cassells device that costs £2,000 or £3,000. We use them on site at every source and at the recirculating filter. So we are able to build a map of sorts to the client. It's not detailed, but it does indicate that the level of control at one particular machine, you know, is significantly less than at another. It just adds another layer to the information that you're giving the customer. What I feel the HSC are going to end up recommending is that filters need to be labelled with their efficiency and what they're made of. That doesn't happen at the moment with most fabric filters. Equipment will need to be labelled with the date that the filter has been changed. These are cheap, simple changes that the HSC feel are proportionate to the risks. And as an alternative to requiring people to change filters on a time-based factor rather than a usage-based factor, they may well end up recommending that the user's risk assessment can determine if they don't need to change them on that time-based factor, and that would be based on information feeding into their risk assessment, like some static sampling or some sampling with an appropriate handheld device. So I think they are going to come up with proportionate solutions for us. And I know it's something that we all want, but it's not available to us now. And I think we have to wait a little bit longer until a bit more of this information is available before we can develop the guidance that everybody is after. But it's good to talk about it.
I've got to go as well now, and I just wanted to say I found it all really interesting and worthwhile. So thank you to everybody. And I just wanted to award the best coffee cup to Mark Armstrong. Mark, can we just have a quick look at your coffee cup again? Brilliant. Thanks a lot. Bye.
Bye. I think if we wait for the HSE, it never happened. I have no faith in them at all. In delivering, they haven't really delivered for the LEV industry. They've done 258. What else do they really do for the industry? You know, what have the Romans ever done for us? That we've asked them for guidance, we've asked them for support on things. Yes, they turn up to the conference, and yes, they do a talk, but they didn't really commit to anything. And we're left as an industry trying to sort it out ourselves. So I think if we do want this guidance, it has to come from within the industry, from the volunteers, to put it together. Whether that's an LEV thing, whether it's someone else, another organisation, whether it's LEV Central, I don't know. You know, but that's where it will come from. My experience with HSE over the last year is they're too busy with COVID, and then there'd be something else, and it'd be something else, and it'd be something else. Not a high priority for them.
I think until that time when we've got a clear guidance, I think what Jane just mentioned is an ethical approach. So obviously there is a number of different real-time monitors, but I think if we would look into the options of trying to determine the respirable particles in the real-time monitors and using it next to the filter and then measuring, let's say 3, 4, 5 different locations away from the place where the works is happening, away from the filter, that will give a quite good understanding and a comparison of what's happening behind the unit's filter and somewhere else in the workplace where we see this place being likely not contaminated. So I think from an ethical point of view, that's, I think, the best that we can currently do. And I just say from an occupational hygiene perspective.
I really do need to go, but I would be happy to put together the guidance that I give my own employees on how they should use direct reading instruments and where they should use them and how they should express those results, with other members of the LEWICKI steering committee for their input on that. And perhaps LEWICKI can put together a guidance document initially that we then circulate for review to other members of the industry for their input, because I do appreciate the HSE take a very long time to do things, and I'm now 7 minutes late for my next meeting, which is nothing new. It was lovely talking to you all and to see most of you, and I look forward to seeing you all again. Bye bye.
See you, Jane.
Bye, Jane.
Bye.
I will just add to that. I'm glad Jane's going to do that. She wasn't at the LEWICKI meeting last week, earlier this week rather. This is one of the things that LEWICKI are looking at doing, and I mentioned it earlier. So that sort of thing is exactly what we're after. There's many people who want to be involved, because we don't want to make it an LEWICKI thing. We want to make it an industry thing so that everybody buys into it and everybody can put their point of view in. So as I say, please do get involved, because we're looking at doing that from LEWICKI and hopefully getting everybody involved too. Now, if you haven't got my contact details, just go to ilevy@sibsi.co.uk. I think that's the, and it will get back to me. Or to Adrian. I think most people know Adrian's email. Anyway,
That's good. I think it's probably a good time to wrap the meeting up. But thanks so much, everybody. Yet again, it's been really informative, and I've taken quite a lot away from this, even though I couldn't participate for the first half.
Thanks for organising, Louise. Thank you.
No worries. Thank you for being present.
Yeah.
Thank you, Louise.
Thank you.
Good weekend.
Bye all.
Okay then. Bye all.
Cheers.